This is video 2.5.1, and the goal here is to be able to find the factors of polynomial functions in order to solve. So our goal is to find the factors that will help us solve. So we have this polynomial. So in this example, we'll talk about the factor theorem in a second, but the example 2x to the third minus 3x squared minus 11x plus 6 equals 0. This polynomial, this equation, is only solvable if we factor out the function that's equal to 0. Then we can figure out, okay, well, what makes this 0 and what makes this 0 and so on. This is the zero product property. You did this when you started to learn how to solve quadratics back in Algebra 1, and now we're using it to solve polynomials. So this is the zero product property when we take it and make it equal to 0. So now we're going to be doing that for this one, and a couple of things. We're going to use synthetic division because it's quick, and here's why, the factor theorem. If dividing by x minus c gives you a remainder of 0, so if when we use synthetic division we get a remainder of 0, then x minus c is a factor of the polynomial. Just think about it, we're dividing the function by x minus c, and if it comes out evenly, that means I can rewrite it as a product. It means that something times something will equal that function, and we found one of those factors. So let's take a look at what that means here. So notice they were nice and they gave us a 0. So we're going to use that in our synthetic division. We're going to put our 3 in, okay? Because if 3 is a 0, that means x minus 3 is a factor of my function, because that would make that 0, 3 would. And now I'm going to synthetically divide. Since it's so easy, I'm going to synthetically divide out my polynomial. So remember, we drop the 2. We do 3 times 2 is 6. Add the result. We get positive 3. Again, we multiply. 3 times 3, we get 9. Add the result. We get negative 2. One last time, 3 times negative 2, we get negative 6. We end up with a result, a remainder of 0, just like we talked about. So this remainder of 0, remember, we always drop this power, so we're ending with x squared, x, and negative 2. So my polynomial here is the result once I divide by that term. So since working backwards, it means that x minus 3 times this polynomial will equal my original function that we saw up here. So we've already started to factor it. We have one factor, x minus 3, well, mostly because they gave that factor to us. So we're going to continue on now and continue factoring, because our whole goal is to solve this equation. We found one solution, 3. They really gave it to us. But now we're going to continue on because we have this function that we factored into the following form. But now we need to factor that even further. So now we're going to take and we're going to factor that more by factoring out the polynomial that has a degree of 2. So we're going to factor that one further. Now I'm going to kind of talk you through how I do some of this in my head, and I don't draw a generic rectangle. As you get the hang of this, you can try this method, but I'm trying to think about how to multiply this. It's only an x squared, so it can't be that hard. I'm going to guess and check in my head. I know the only way to get 2x squared is 2x times x. And when you FOIL, the first two terms, the highest degree there, make the x squared. So I've got my 2x squared taken care of. And remember, again, the last terms always create the negative 2. So together those have to create negative 2. There's a couple ways to do that, negative 2 times 1 or negative 1 times 2. So there are a couple of options here. So I start to look and make an educated guess, and I notice, hey, this adds to 3x. So 3x has to be created. So I'm kind of tempted to create 4. And I'll tell you what I mean by creating 4. So this is what I'm tempted to do. Because if I multiply this 2 times this 2 and do the outer terms, I get 4x. And when I multiply the inner terms, I get negative 1x. And that adds to 3x. Okay? So this is how I do it in my head. Now you continue to use your generic rectangles and diamond problems, but I know some of you are itching for a better way or just a faster way that takes up less paper. So this is one way you can do it in your head, but you've got to be careful. You can't just rush through these things. So use that as an idea, but don't do it if you're making mistakes. So now we finished factoring. I have the factors x minus 3, 2x minus 1, and x plus 2. And my whole goal is to be able to solve the equation. That's what the question's asking. So we have one solution right here, x equals 3. Because if this function has to be 0, this expression, this equation over there wants to equal 0, then x has to be 3 in order to make this first one 0. And then we ask ourselves again, what will make this 0? Well, that's when x is 1/2. Again, I'm doing some of that in my head, but all you do is you ask the question, when is it 0? So you write 2x minus 1 equals 0, and you solve. And that's how you get 1/2. And then we're going to ask, okay, when is this next one 0? When is x plus 2 0? Well, that's when x equals -2. So these are my 3 solutions to this polynomial function, this third-degree function that I was trying to solve. So I have my 3 zeros, my 3 solutions to the polynomial, and I'm done. That's all the question was asking for. But this will get cumbersome to have to factor every time, and what about when the degree gets higher than 3? We'll have lots of things to test. So we're going to talk about a way to do this and a way to list all the possible zeros of a polynomial. So that's our goal. Part of your checkpoint will be looking at how can you find all possible zeros of a polynomial. If we want to find all possible zeros, it starts simply with number one, understanding we're only looking for zeros that are rational numbers. So fractions, nice decimals like 0.5, but not irrational numbers like square root of 2 or 1 plus the square root of 3. We don't want those types of roots and zeros. We want simply nice integer whole numbers or fractions. Okay? So the way we're going to find them is going to be a ratio P over Q. Okay? And what P is? So P is the factors of the constant. The constant in a function is always this number that gets added on. It's the number that's not dependent on an x. So when I'm listing the factors of 4, the possible values for P are positive or negative 1. That's always going to be an option. For every number, positive or negative 2, and positive or negative 4. Those are 6 numbers that go into 4. Those are the values for P. Q is very similar, but now Q are the factors. Q represents all the factors of the coefficient of the highest power of x. So the factors of the coefficient of the highest power of x is what you're looking for when you're looking for Q. So here's the highest power, x to the 4th, and our coefficient is -1. So for Q, the only possible values are positive or negative 1. Those are the only factors of -1. Okay, so we're looking only at integer factors. We're not going to look at fractional or decimal. But the way we'll list all the factors, the possible zeros of the polynomial, is by simply writing the ratios of P over Q. Okay, so the different numbers are going to be, since Q is only 1, does it really matter if I divide by 1 or -1? It actually doesn't change anything. So the possible zeros for this problem are simply going to be the zeros of P. And you'll find that's the case for a lot of them. It always starts with a list of the P values, but we also want to look at the division if we divide by Q. So the possible zeros are positive or -1, 2, and 4. So this narrows our list down to 6 choices. And this is going to be helpful because we're simply going to take these 6 choices and start testing things with synthetic division, which we see goes really fast, it's really short to write out, and it's pretty easy to do. So let's take a look at another example. So we're going to first think about what are the possible zeros, and the possible zeros, remember, are the factors of the constant divided by the factors of the highest power. So the factors of 24, there's a lot of factors of 24. We can do 1, 2, 3 goes into 24, 4, 5 doesn't, but 6 does, and then 8, and we even have 12, plus or minus 12, and 24. So 24 is kind of a mean one. So this one looks really daunting because there are, well, how many are there? There's 16 possible factors of 24. That's quite daunting, so don't get worried about that. What you do is you eliminate some of the bigger ones if the numbers here are pretty small. So you don't necessarily get rid of them completely, but you don't start with those. Those don't make a very educated guess, okay? Typically starting somewhere in the middle is a good idea. So to solve this function, we're simply going to divide synthetically until we find something that works. So we're going to try like 3. Now notice real quick before I move on, I didn't even bother to look at the coefficient here because it's just 1. The only thing that goes into 1 is positive or negative. And when I divide by positive or negative, I just change to positive or negative. It doesn't change the value of the number. So it doesn't change my list of possible zeros. So let's take a look here. We're going to start our synthetic division. We're going to fill in a 0 for the x to the third because there isn't one. And I'm just trying 3. Okay? So synthetically dividing, we drop the 1, 3 times 3. 3 times 1 is 3. Add, multiply, we get 9. Add, we get 3. Multiply, we get 9. Add, we get 1. 3 times 1, we get 3. And it looks like we're not going to get 0. And that's our whole goal, is to completely factor and get rid of something. So 3 did not work. You could quickly jump to -3 just because it might be easy to not erase everything, because it would change this. It would change this to -3. This would still be positive 9. This would still be positive 3. Multiply, now we get -9. Add, we'd get -17. Multiply, we would definitely not get 24. So -3 is also not a 0. So I've eliminated this option. Okay, so now I'm going to test for, I don't know, 2 or 4. Let's try 2. So I'm going to leave the same exact original part of my synthetic division, but now I'm going to try 2. So we drop the 1, multiply, we get 2, add, we get 2, multiply, we get 4, add, we get -2, multiply to get -4, add to get -12. Looks like I found one, and I get -24, and I get 0. So I've got the factor 2 coming out. One thing to note, you're going to take now your result and you're going to synthetically divide that now. So the good news is everything gets shorter here on out. You'll have less calculating to do. But we're still going to guess and check which factors it is. But one of the factors you can eliminate right now, there's 2 sets of factors you can eliminate. 24 does not go into 12. So remember, your list of factors should be numbers that go into the first and last coefficient. Of course, this is P, remember, this is Q. The factors of 12 and the factors of 1. Well, the factors of 12 are 12, 6, 4, 3, 2, and 1. So notice I can eliminate 8 and 24. So I've got those gone. They're done. Okay? So I've already slowly decreased some of my options here. But now I'm going to take a look at trying some of these other factors. So let's take a look, try 4. So we'll put 4 in, drop the 1, times it, add it, multiply it, we get 24. Sorry, I didn't put my solution line here. Add it. Ooh, I'm starting to see this is going to get way too big, because 4 times 22 is huge. It's definitely not going to add to 0. So I'm going to stop when I realize it's wrong. But one thing I'm going to do is I'm going to switch this over to negative right away because it's quick and it's easy. So I'm going to change this to -4, add it, change my solutions here. I'm going to get -2. Instead, when I multiply, I'm going to get 8. Add it, I'll get 6. Ooh, so close. It was getting smaller, but not small enough. Okay, so it did not make a remainder of 0. It made a remainder of 36. So -4 is not my solution. So 4 and -4 are out. So now I try something else. But here's one thing I want you to keep in mind. Don't get rid of a 0 you've already found. Remember this 2, just because 2 went in doesn't mean it won't go in again. So sometimes you get stuck and you keep trying things and you forget to try the same number. If 2 goes in twice, that's okay. It just means it's going to be factored twice with the 2. So let's try. 2 times 1 is 2. Add them, we get 4. Multiply, we get 8. Add, we get 6. Multiply, we get 12. And we end up with a remainder of 0. So sometimes that happens, which is why I did this example. So this particular polynomial has 2 factors of 2. The third factor is x squared plus 4x plus 6. And that equals 0 because that's our whole goal, was to solve for the zeros. So far I'm at this point. So this is where I remember where I'm getting this. This right here is the result when we synthetically divided. We were down to the x squared function. And then the x minus 2's, those are both from these 2 zeros, these 2 roots that I found using synthetic division. So at this point, I would see, oh yes, we're finally at the point where we have a nice, simple quadratic, okay? So the quadratic here, I want to try and factor, but if I think in my head what multiplies to 6 but adds to 4, nothing comes to mind. 3 times 2, 6 times 1, those are the only ways to get 6. Whenever you hit a quadratic, your last chance is to use the quadratic formula. So I'm not going to go through how to do that, but I want to show you the 3 roots. So the answer is x equals 2 or, and then we'll have our 2 zeros from the quadratic formula. The solutions end up becoming imaginary solutions, but we still want to provide them, and the 2 solutions are -2 plus or minus I square roots of 2. Don't forget all your rules for simplifying radicals and simplifying imaginary numbers, making them proper. So these are the 3 solutions, because one is when we add, of course, I square roots of 2, and one is when we subtract I square roots of 2. So those are your 3 solutions to this quadratic, this polynomial, this 4th degree polynomial. So your goal for tomorrow for your checkpoints, you're going to do 3 parts for these 2 questions. You're going to list all the possible zeros. So that's that nice long list. If I show you back to the example, it's a nice long list of all the zeros like you see up at the top here for 24. Okay, don't be afraid to try and write the ratio of P to Q. And then your goal is to use synthetic division to find and test possible zeros. Okay, so that's your #1 goal. And then find all zeros by factoring them that you found. So your goal is to try and rewrite these in factored form. So in the end, I could have up to 4 factors for this one. And for this one, I could have up to 3. But use synthetic division to try and work through that process and try to get there and bring your questions to class.